We haven't found any alien life out there yet. But it could be we're just not looking for the right things. There's a team of scientists, part of something called Project Hephaistos, which was specifically created to look for Dyson Spheres. And just recently, this team of scientists were looking over the photometric data of millions of stars. And after complex filtering of these objects, they found 7 stars in the Milky Way Galaxy that have excessive infrared radiation that cannot be explained. The next step is to perform an optical spectroscopy, which will reveal more detail about these stars. Could they be Dyson Spheres? For now, no one can be absolutely sure. But the big question is, would it be really possible for an alien civilization out there to build a Dyson Sphere around their star? And how would they do it? Advanced civilizations are measured on a technological scale called the Kardashev Scale. Created in 1964 by Soviet astronomer Nikolai Kardashev, it's a serious scientific framework for understanding the different levels of technological civilizations, including our own. One thing we can clearly see is the human technology is advancing by leaps and bounds. With the way that AI seems to be advancing these days, it looks as though we're about to go through a great technological change. And the Kardashev Scale offers us a roadmap to the stars and beyond. So let's take a look at each type of civilization and the mind-bending possibilities they represent. Find out where we need to be on this scale and what we need to build a Dyson Sphere. While not part of Kardashev's original scale, many scientists now include Type-0 to represent our current state. We're a civilization still bound to our home planet, reliant on finite resources and only just beginning to harness the true power of our world. We're not really that advanced when you look at our current activities. We burn fossil fuels, we've started to tap into wind and solar energy, and have just begun to unlock the potential of nuclear power. Yet we remain vulnerable to planetary disasters, climate change, and the depletion of our natural resources. Our reach extends only to our nearest celestial neighbor, the Moon. Although we have sent robotic spacecraft to other planets. When you look at all this, it doesn't really seem like much yet. But make no mistake, we're a civilization on the edge of greatness. Our quickly expanding technological growth hints at the immense potential lying dormant within our species. As we speak, scientists are working on fusion reactors that could revolutionize our energy production, while visionaries dream of unimaginable cosmic things such as space elevators and Dyson Spheres. The jump from Type-0 to Type-1 is perhaps the most critical in our evolution. It's a transition full of challenges, requiring us to overcome our tribal instincts, unite as a species, and learn to manage our planet as a single, sustainable system. If we can do that, we can move on to the next level. As we ascend to the first official rung of the Kardashev Scale, we begin to enter the realm of science fiction. A Type-1 civilization has achieved mastery over its entire home planet, harnessing and controlling all available energy. Imagine a world where we can manipulate the weather at will, preventing hurricanes and directing rainfall to arid regions. Picture vast solar arrays covering deserts, wind farms spanning entire mountain ranges, and a global network of fusion reactors providing clean, limitless energy to every corner of the globe. A Type-1 civilization would have the power to reshape continents, create artificial land masses, and even begin the terraforming of other worlds in their solar system. They would have total control over their planet's resources, recycling and repurposing materials with incredible efficiency. But energy isn't the only hallmark of a Type-1 civilization. They would likely have achieved a level of global cooperation and governance that seems utopian by our standards. Wars over resources would be a thing of the past, replaced by collaborative efforts to push the boundaries of science and exploration. A technology of a Type 1 civilization would boggle the imagination. Artificial intelligence would be seamlessly integrated into daily life. Nanotechnology would revolutionize manufacturing and medicine, and the first steps towards true space colonization would be underway. Yet for all those amazing advancements, a Type 1 civilization is still bound to its solar system. The vast gulfs between stars remain an obstacle, but it wouldn't be for long. If a Type 1 civilization represents mastery over a planet, a Type 2 civilization extends that dominance to an entire star system. This is where the lines between reality and science fiction begin to blur significantly. A Type 2 civilization harnesses the entire energy output of its parent star, and that's where the Dyson swarm or sphere comes into play. While a solid sphere is likely impossible, a swarm of satellites or a ring-like structure could serve the same purpose. With the power of a star at their disposal, a Type 2 civilization would be capable of feats that would appear godlike to us. They could move planets at will, perhaps to escape the eventual death of their star. They might create artificial habitats the size of planets, offering living spaces for trillions. Immortality could be within their reach for such a civilization. With their incredible energy resources and advanced technology, they may conquer aging and disease and begin transferring consciousness to artificial bodies such as robots or even pure energy states. Interstellar travel, while still challenging, becomes feasible for a Type 2 civilization. Generation ships or advanced propulsion systems could allow them to send colonies to nearby star systems, beginning the long process of expanding their influence beyond their home system. The computational power available to a Type 2 civilization is almost unimaginable. They could create simulations indistinguishable from reality, perhaps even spawning new universes. The line between the physical and the virtual would blur, opening up entire new realms of existence and experience. Yet, even at this level of advancement, a Type 2 civilization would be largely confined to their local stellar neighborhood. The vast distances between galaxies would still pose a significant challenge, but for a species that can harness the power of a star, no challenge is too difficult. Now we truly enter the realm of the cosmic. A Type 3 civilization has transcended the bonds of a single star system and has harnessed the energy of an entire galaxy. This is a level of existence so far beyond our current state that it's almost impossible to visualize. A Type 3 civilization would have colonized and utilized millions or billions of star systems. They would have mastered faster than light travel, or found ways to circumvent the light speed barrier through wormholes or other exotic means. The concept of distance would have little meaning to such beings. The energy at the disposal of a Type 3 civilization is truly astronomical. They might tap into the power of supermassive black holes at the centers of galaxies, extract energy from the very fabric of space-time, or utilize dimensions beyond our comprehension. With this level of energy and technology, a Type 3 civilization could reshape the structure of their galaxy at will. They might move stars to create vast Galactic scale engineering projects. Perhaps they would create artificial structures the size of solar systems or even larger. The beings of a Type 3 civilization may have long since shed their original biological forms. They could exist as pure energy, as vast networks of artificial intelligence, or in forms we cannot even imagine. Their consciousness might span the entire galaxy, turning it into a vast living superorganism. For a Type 3 civilization, the manipulation of matter and energy would be trivial. They could create or destroy stars at will, ignite new galactic cores, or even prevent the heat death of the universe in their domain. They might be able to alter the very laws of physics with this scale of power. Yet, even at this godlike level, there are still higher rungs on the cosmic ladder. Kardashev's original scale ended at Type 3, but theorists have proposed further levels that stretch the imagination to its limits. Type 4 civilizations would extend their influence beyond a single galaxy, perhaps commanding entire galactic clusters or even a significant portion of the observable universe. At this scale, the manipulation of dark energy and dark matter would be commonplace. A Type 4 civilization might be able to create new universes, either by inducing local inflation events or by engineering reality at its most fundamental level. They could be the cosmic gardeners, seeding new life throughout the cosmos or shepherding younger civilizations up the Kardashev scale. Some have even proposed a Type 5 civilization, one that has mastery over all possible universes and dimensions. Such a civilization would be, for all intents and purposes, omnipotent and omniscient, indistinguishable from what we might consider gods. As we stand here on Earth, a young Type 0 civilization taking our first tentative steps into space, the higher levels of the Kardashev scale might seem like nothing more than a fantasy. Yet it's worth remembering that barely more than a century ago, the idea of humans walking on the moon was considered pure science fiction. On the Kardashev scale, a civilization capable of building a Dyson Sphere would be Type 2 status. A Type 2 civilization can harness the entire energy output of its star, while a partial Dyson structure, such as a swarm of satellites, might be achievable for an advanced Type 1 civilization. A full Dyson Sphere would likely require capabilities well beyond our current level. To appreciate the magnitude of a Dyson Sphere, let's consider the size of our Sun. The Sun's diameter is about 864,000 miles. You could fit 1.3 million Earths inside the Sun. A Dyson Sphere around our Sun would need to have a radius of at least 1 astronomical unit, or AU, the distance from the Earth to the Sun, which is about 93 million miles. This would create an internal surface area of approximately 108 quadrillion square miles. That's about 550 million times the surface of the Earth. Constructing a Dyson Sphere would be an engineering feat of cosmic proportions, but here's how we might start to do it. The first thing we would need to accomplish in building this mega structure would be to gather enough materials and resources. Our planet alone wouldn't have the resources needed to build such a structure. The materials would need to come from several of our neighboring planets, or even by harvesting asteroids and comets in our solar system. The planet Mercury could provide a significant amount of material. The best idea to begin with would be the Dyson Swarm, using self-replicating robots. Using self-replicating solar-powered robots is one of the most plausible methods proposed for building a Dyson Sphere. These robots, something like von Neumann probes, would be crucial for a project of this scale. It goes without saying that artificial intelligence is going to play a big part in these self-replicating robots. The robots would start by building solar collectors and energy transmitters. As more energy is harnessed, it would be used to power more construction. The swarm of collectors would gradually grow, encompassing more and more of the Sun. The time required to build a Dyson Sphere starting with a swarm is difficult to estimate because it depends on factors far beyond our current technological capabilities. However, we can make some educated guesses. With current technology, it's likely to take millions of years. However, with highly advanced, self-replicating robots, the process could potentially be completed in a few hundred to a few thousand years. The rate of construction would likely follow an exponential curve, starting slow but accelerating rapidly as more of the Sun's energy is captured and more robots are produced. Robots would make more robots, and those robots would build more solar collectors, and so on. Eventually, the collection of solar collectors would begin to physically connect to each other and become a full Dyson Sphere. Gravitational stability will then become the first big problem. Keeping the structure in place around the Sun would require incredibly advanced engineering. The second problem to be solved would be heat dissipation. All that energy coming from the Sun would be hard to control at first. Managing the captured energy without melting the structure would be crucial. and we'd need to develop materials far stronger and lighter than anything currently known to us. But these wouldn't be the only problems. The construction itself would require levels of precision far beyond our current capabilities. But this is something that a Type 3 cosmic architect would surely overcome. Do you think that humanity could one day achieve this incredible feat? Let us know in the comments. Although we found some stars that appear to be consistent with Dyson Spheres, it's too early to assume that megastructures are the cause of weird star behavior, and more observations are needed. It could be space dust, rocks, or something else causing the weird behavior. But for now, we just don't know until more research on the data is completed. Who knows what we may find? Researchers have found a lot of weird objects that defy what we know and exactly zero aliens. So we should expect this pattern of discovery to continue until, hopefully, one day it doesn't. For humans, at least 100,000 years are needed to become as advanced. And it could even take 1 million years to become a Type 3 civilization if we ever survive long enough. But do such civilizations exist? And if so, such an intense technological activity would be easily observable in space. According to NASA, we found about 4,000 planets outside our solar system in the past 2 decades. And in the Milky Way alone, there should be trillions of stars accompanied by planets. So why haven't we found any signs yet? This is called the Fermi Paradox, and it says that our universe is too old and too large for there not to even be a single other life except for the one we have on Earth. But throughout decades, we haven't found anything like that. But we may not have looked hard enough. The ongoing search for extraterrestrial intelligence is limited to catching several frequencies of radio and TV emissions. The problem is, such signals could only be made by a Type 0 civilization. And because they also interfere with static charges in space, a good portion of that signal is lost. A much more effective way would be to break signals into all frequencies to preserve most of that signal. Sadly, a hypothetical Type 0 civilization using only one frequency wouldn't be able to read that message fully, hearing nonsense instead. So even if the Milky Way is loaded with a variety of messages from Type 2 or Type 3 civilizations, human Type 0 radio telescopes cannot hear them properly. Another researcher at the National Astronomical Observatory of China came up with a new theory of where those civilizations could be hiding. A professor and her team scanned a significant portion of the sky and detected 21 galaxies. They were searching for unusual radio signals to detect alien exhaust, and the 2 weird galaxies they've discovered had enhanced infrared emissions that couldn't be explained by natural phenomena. Astronomers hope it could point to a bunch of Dyson Spheres and entire galaxies captured by an intelligent civilization or civilizations. But to prove the idea, they need to know for sure what's causing these infrared emissions. There's also another solution to the Fermi Paradox. Perhaps these civilizations have decided to stay unnoticed. Our universe is vast, and just because we haven't succeeded in finding anyone doesn't mean they're not there. When looking for signs of technologically advanced civilization, astronomers often base their observations on different types of infrared emissions and waste. But what if a super-intelligent civilization has not only come up with unimaginable technologies, but also found a way to hide its presence? If so, all this time, we've been searching for something we shouldn't and neglected what demands our utmost attention. If we continuously fail at finding any signs of extraterrestrial civilization, we could try studying what's missing instead. Because the most likely scenario is, if a Type 3 civilization existed somewhere out there, it would gather all the energy available in a galaxy and exhaust all its power supply, leaving nothing behind. And there are such empty regions in space, the Great Voids, which were once believed to be signatures of intelligent life, but this theory was refuted. And although scientists haven't lost hope, most of their studies eventually come to a dead end. And if that's always the case, there arises another question. What if we just came to be at the wrong time? According to one computer simulation, intelligent life could have been more abundant 4 billion years ago than at any other moment. It may seem unbelievable, but if primitive life existed on Earth roughly 3.5 billion years ago, why couldn't intelligent life exist elsewhere in the universe at about the same time? And should we even try so hard to satisfy our natural curiosity with the threat of possible extermination of human beings as a species? We all come from one ancestor, and we cannot restrain our anger towards each other. So, should we think that a hyper-advanced civilization would care more for our lives than we do? Today we're scared of exhausting our planet's resources. Type 2 civilization would be afraid of the death of their star, and Type 3 civilizations would be concerned about how to escape the death of the universe. But if we look at the broader version of the Kardashev Scale, for a Type 4 or even Type 5 civilization, even that wouldn't be something to worry about. These creatures could theoretically form a new universe. And according to one physicist, the energy needed to give birth to a baby universe in a laboratory would require about 1,000 trillion degrees, which is far below the limit of such a civilization's capabilities. Although Type 4 civilization is hardly ever achievable, it would literally mean becoming the creators of everything we could ever observe, think, or imagine. Given how fast we evolve, and that even today the creation of effective tiny laser-propelled spacecraft are within our arm's reach, it could be true that we've already been visited in the past, and the odds of noticing their presence almost equal zero. Even now, we may be observed by a much more advanced civilization that just waits till we make enough progress to eventually get in contact. Or maybe they've already decided to reach out, but it will take hundreds of thousands of years till they arrive here from another galaxy at the other corner of the universe. But even if we don't find anybody, it doesn't necessarily mean a bad thing. Sure, we would feel lonely and maybe even abandoned, but this would also mean that we have the chance to set the foundation for the future stages of human evolution. One day, those hyper-intelligent creatures, somewhat resembling us in appearance, could think of us as pioneers, explorers, blindly discovering this dark place we were put in as a child discovers the world. Maybe it's all our imagination that makes us think they exist, and maybe they do. But it's not them, it's us. Future us. Superhuman beings. If multiverses turn out to be their new reality, civilization of Type 5 will conquer these worlds, harnessing an almost inexhaustible source of energy along their journey. And hypothetical white holes, which are considered the opposite side of black holes, could be the key to achieving this. Meanwhile, science will actively delve into the study of higher dimensions, unlocking secrets and possibilities that were once thought to be fiction. According to scientific theories, a Type 6 civilization would become multi-dimensional. If humans were to enter the fourth dimension, which is a hypothetical spatial dimension beyond the 3 dimensions of length, width, and height, our physical bodies wouldn't be able to exist or function in this realm. Scientists think that the physical laws and properties of objects would behave differently in the fourth dimension, making it incompatible with our 3-dimensional bodies. But for our descendants, who have risen to Type 6 civilization, this may not be a problem. Theoretically, they could learn to preserve their consciousness as pure energy that can be transferred from one dimension to another. The only obstacle could be energy resources needed to make such a transition. But maybe a Type 6 civilization will be able to extract energy from white holes across multiverses. Although purely hypothetical, whoever inhabits this new reality would move beyond the speed of light, travel back and forth in time, and overcome cause and effect limitations. After hearing all this, you might think there's no further level to advance to, but there may be another tier, the utmost peak of civilization's progression. A Type 7 civilization would consist of the creators of all laws of nature, matter, energy, space, time, and dimensions. We cannot imagine what life in a civilization of the 7th type would look like, or if such a civilization can even hypothetically exist. In this unfathomable universe, completely different physical laws would reign. Even if we were to gain access to them, we would never understand them. In theory, it would take us 10 duodecillion years to become a civilization of this type. Another idea is that we will never reach the 7th level because it's not a community of beings, but rather existence itself. We wouldn't even notice if such a civilization existed in the first place. Contemplating the possibility of extraterrestrial intelligence is a captivating subject. However, the search for evidence of such advanced civilizations is quite a challenge. Looking for civilizations in the lower levels of the Kardashev Scale would be a more realistic pursuit. The theory of different types of civilizations provides clues for the search, particularly on exoplanets with conditions suitable for life. According to NASA, there are potentially 300 million such worlds in our galaxy, although we've only studied about 55 of them so far. Advanced telescopes like the James Webb Space Telescope are not just looking for signs of biological life, but also signs of technological activity. Astronomers believe that with the modern equipment we have today, they would have already detected signs of a Type 1 civilization if it existed in the regions of space we've already studied. In this case, extraterrestrials would be traveling through space at speeds that would make their ships noticeable. A Type 2 civilization is also unlikely to remain completely invisible to us. In order to gather energy, it would need to surround stars with Dyson Spheres. If a Dyson Sphere were constructed at the same distance from the Sun as the Earth, and if it were stable, it would enclose a space of approximately 600 million times the surface area of our planet. In other words, the interior of the Dyson Sphere would be vastly larger than the surface area of the Earth. According to Dr. Robert L. Forward, such a megastructure with a radius of 1 astronomical unit would require approximately 10 to the 27 kilograms of material, which is roughly equivalent to the mass of Saturn. However, this estimate assumes a solid shell and may not take into account the technological challenges of building such a structure. It would take a lot of building materials and energy to make stars go dark by encompassing them with Dyson Spheres. Nothing like this has been detected in the Milky Way yet. However, there were a few times when scientists thought they had found something like a Dyson Sphere. When the SETI Institute detected a signal coming from the star HD 164595, 92 light-years from Earth, astrophysicists hypothesized that only a Type 2 civilization beacon could send such a powerful signal, but it turned out to be just a military satellite orbiting Earth. And in 2008, astronomers detected an exoplanet orbiting a super-bright orange dwarf star and dubbed it Fomalhaut b. At first glance, the planet appeared as a bright and cold point of light that quickly moved across the sky. However, in 2014, the planet had vanished, leaving scientists to ponder the reason behind its disappearance. Some suggested that the planet's orbit may have become unstable, causing it to drift away from its parent star. Others proposed that Fomalhaut b had migrated to orbit a different, larger and brighter star elsewhere in the galaxy. It wasn't until later that researchers discovered that the celestial body was not actually a planet, but rather an enormous cloud of frozen debris. This debris is thought to have formed from a massive and violent collision between two icy asteroids, an extremely rare phenomenon. Although we may never know for certain what happened to Fomalhaut b, it's possible that a Type 2 civilization was in need of building materials for their next megastructure, such as a Dyson Sphere. Given the uncertainty surrounding the disappearance of stars, it begs the question of how we would even begin to trace the activity of a Type 3 civilization. Civilizations of Type 3 are either very rare or simply don't exist in our local universe. Astronomers have searched for them using the infrared telescope WISE, expecting to detect large amounts of infrared radiation that such highly advanced civilizations would emit. So far, no signs of such activity have been found, but astronomers remain hopeful. It's hypothesized that a Type 3 civilization may be hiding in giant cosmic voids, the origin of which is not yet fully understood. One particular area of interest is the Buetz Void, which is almost entirely devoid of stars and galaxies and has a diameter of 330 million light-years, making up approximately 0.27% of the diameter of the observable universe. According to scientific speculation, the empty space may be attributed to the various kinds of activities by an advanced Type 3 civilization. It's possible that some extraterrestrials have been obscuring entire galaxies one by one, covering their stars with Dyson Spheres or moving them to the desired location. Scientists hope that Earth's technological advancements will allow them to test this hypothesis in the near future. Do you think we'll ever find intelligent life out there? And if we do, should we ever try to get in contact? Sound off in the comments and stay tuned here to know about the most mind-boggling cosmic discoveries. Thanks for watching.